Bootstrap, bootstrap.
I don't know. Next
And
question.
there is okay. Uh, uh, there is one more question: how to take normality of a data and homogeneity of variables or variances. Kishore is asking how to test normality of data and homogeneity of variances.
Okay. For testing the normality of the distribution, you should calculate the kurtosis. And if the value of the kurtosis is 0.262, I repeat, the kurtosis value must be 0.262, then it is a normal distribution. Okay, and for testing the homogeneity of variance, there is a inbuilt test in the SPSS, and yesterday also I told you it is a Levin's test for equality of variances. So you can use that. Next question.
There is a question from Asima, and she is asking that she is calculating income like 1,000 to 5,000, 5,000 to 10,000, 10,000 to 15,000. So how can I use t-test in this?
Now, see, when you have so many categories, so what do you want? The important is what is your continuous variable. If you do not have one continuous variable, you cannot do anything. So this question is incomplete. So she should once again reframe her question, and then she can ask what exactly she wants to ask.
Okay. Next question is from Vijaya, and she is asking how to write interpretation on the basis of p-value, probability value.
I have already given the interpretation yesterday. So therefore, she should have been careful at that point of time. Next question.
Okay, Chintamani is asking a question how to import data from Excel sheet.
That I will tell you on 21st. Do not worry about it, because right now till 20th I have less time, but after 20th I will have more time, and I will not complete my lecture at 5 o'clock. I can continue up to 5:30 or so. At that point of time I will explain. Do not worry.
Okay.
Next question.
There is a question from Sachin. What is the limit of digits in SPSS?
Now, there is no limit of, there are limits, and it is very high. You can see, I will tell you when I have the SPSS, I will tell you the limits of the decimal as well as the whole number. And you can see yourself, it is there. Next.
Dr. Abhiram Banerjee is asking that in case of correlated t-test, if the dependent variable is normally distributed in baseline, in pre-test, but not normally distributed after intervention, that is the post-test. Can we go for correlated t-test, or should we opt for non-parametric counterpart?
No, the question is wrong. You repeat the question. I will tell you what is the mistake in the question.
In case of correlated t-test, if the dependent variable is normally distributed in baseline, but not normally distributed after intervention, can we go for correlated t-test or opt for its non-parametric counterpart?
You should go for non-parametric statistics whenever the assumptions of parametric statistics are not satisfied. Then you have to go to non-parametric statistics. Next question.
Okay, Mr. Rajdev, he is asking, is there any method to identify if we have used wrong test for hypothesis testing?
No, there is no method. Only the thing it is you should know whether whatever the data you have and whatever the statistical technique you want to use to test the hypothesis, whether that data satisfies all the assumptions or not. Otherwise, there is no test which will tell you whether you have used an appropriate statistic or not. Only the teacher can, or somebody who is an expert in statistics, he only can tell. Otherwise, there is no software available which will help you. Next question.
Next question is from Vijaya, and she's asking how to test the assumptions for paired samples t-test.
Yeah, it's the same. I told you yesterday, the whatever the assumptions I have listed for the t-test, the same are the assumptions. And therefore, for testing the assumptions, just now I have said, if you have to test whether the continuous variable is having a normal distribution or not, you can calculate the what is known as kurtosis, and the value of the kurtosis must be 0.262. And if this is the value, then it means your distribution is a normal distribution. And for testing the homogeneity of variance, you should use Levin's test of equality of variance, and it is always inbuilt in all the statistical technique which you use with the help of SPSS. Next question.
Okay, sir. Mr. Rakesh Kumar is asking that in a research, how could the scholar decide what should be the sample size? Is there any protocol for that?
Yes, there is a protocol, but we are not going to consider that right now because
Okay.
that belongs to another domain. I have not discussed the sampling. So if you are interested, we will have another 15 days webinar where I will discuss how to write the objective, how to write title, how to frame hypothesis, how to test the hypothesis, how to decide what should be sample size. Everything I will discuss in that. So I cannot take up this particular question because it requires the understanding of sampling. Next question.
There is a question that we have collected data in 5-point Likert scale. Should we use parametric or non-parametric test?
No, it depends upon when you have collected the data, whether it satisfies the assumptions of the parametric statistics, then you use parametric statistics, otherwise you use non-parametric statistics.
Okay.
Next question.
There is a request from Mahadev, and he requests to explain the difference between research hypothesis, statistical hypothesis, and operational hypothesis.
Sorry, I will not be able to do it because it will require a lot of time, and
Okay,
it is not the part of this particular series of webinars. Next question.
That's all, sir. Then we can start today's session.
Okay, thank you very much.
Thank you, sir.
All right. So I will share my screen now. I hope you can see this particular screen.
Yes, sir.
All right. Okay. Now, today I am going to take the another one, and the topic for today is the analysis of variance. Now, this is the one, and here you should understand few things. Otherwise, then you will not be able to really understand it. So try to pay attention. Now, when I say analysis of variance, the important is there has to be one variable having more than more than 2 levels. Please understand, if you have one variable and 2 levels, then you can analyze your data with the help of t-test or independent samples t-test. But if you have one variable where you have more than 2 levels, then you cannot use t-test. And I have seen many people, they use t-test because if there are 3 levels, that means if there are 3 groups, so they will compare one group with second and one group with third and second with third. So they will take two groups and use t-test, which is technically incorrect. You cannot have that. Okay, so this is the one thing that you should understand, that there should be one variable having 2 levels, and then there must be one criterion variable which is continuous. Okay, now since here I am taking one variable having more than 2 levels, so therefore this will be called one-way analysis of variance. Why it is called one way? Because I have one discontinuous variable which has more than 2 levels, and that is why it is called one-way analysis of variance, or you can say one-way ANOVA. ANOVA is the short form of analysis of variance. So whenever you say one-way ANOVA, two-way ANOVA, three-way ANOVA, now you understand, in one-way ANOVA, you must have one discontinuous variable and you must have more than 2 levels. But suppose I have 2 levels, then can I use analysis of variance, one-way analysis of variance? So just now I will tell you the answer of this particular question. Nothing to worry about it. Okay. Now, let me tell you the assumptions which we have to have. Okay. So the assumptions for one-way ANOVA are: one assumption is normal distribution. This is one condition. And another condition is homogeneity. Homogeneity of variance. And in the homogeneity of variance, you know it is S. If S is the standard deviation, then I'll say S1. Okay. And then I'll say square. S1 square equal to S2 square. So I will just change, don't worry about it. So this is S2 square is equal to S3 square. And if you have another one, then it is S4 square. So like this, you can have as many four. Okay. So you can have as many groups as you like. Now, so if you want, you can write it as a general is equal to this Sn. N means the number, and that number may be any. You may have 20, you may have 30, whatever it is. So that if you have 3 groups, then it is S1 square is equal to S2 square is equal to S3 square. If you have 5 groups, then S1 square is equal to S2 square is equal to S3 square is equal to S4 square is equal to S5 squares. So your N can range from 1 to any number, absolutely no problem. Okay. Now, then another is that the criterion variable or the dependent variable, criterion or dependent variable must have data either on interval scale or ratio scale. Interval scale or ratio scale. And then another, there must not be any. There must not be any outliers. Now, these are the assumptions which must be fulfilled whenever you want to analyze your data with the help of one-way analysis of variance. And you see that almost the same were the assumptions for the t-test, for the correlated t-test. And the same will be the assumption for two-way ANOVA, three-way ANOVA, etc., etc. So you just try to understand this. Now, let me just take one objective and then let us try to understand how do we enter the data in the SPSS, okay? And then how do we analyze? And I will also tell you the answer of one question, and that is, I will tell you the question is, what is the relationship between t value and f value when the variable, when discontinuous variable has only 2 levels. This is the question. So I will be answering this particular question, and please try to pay attention when I answer the question, which I have put it in the red. So this question I will answer when I enter the data, I will show it to you. Now, the objective which I want to have, say I have a scenario like this. Say I have the types of colleges. Suppose I have one type of colleges, government college. The another I have aided college. Another I have private college. So I have one variable, and that variable is types of colleges, and this variable is discontinuous. Types of college is a discontinuous variable. Okay, it's a discontinuous variable. Why? Because it has the 3 groups or 3 levels. Now, suppose I want to compare the reasoning, or I want to compare the reading comprehension. Let's say English reading comprehension. English reading comprehension. This is my criterion variable, is the criterion variable because here this I will be doing the survey. It is not an experimental study because there are government school already, aided school and private, colleges, government colleges, aided colleges and private colleges. So I will have a English reading comprehension test and I will administer. So this is survey. It is not at all experiment. I will take one example of experiment also. Don't worry about it. Okay. And here, this is the criterion variable, because in survey, you cannot have the dependent variable. Okay. And here I have written discontinuous variable. I have not written independent variable or dependent variable. It is a discontinuous variable. Okay. And so if I have the colleges now, then the objective which I want to write is like this. Objective will be to compare mean scores of English reading comprehension. Mean scores of English reading comprehension of students studying in government, aided and private colleges. Please say this will be my objective, and because there are 3 groups, one is government, other is aided, and the third one is private. And English reading comprehension is a continuous variable. So therefore, I will be, okay, is a criterion variable, but it is discontinuous. But it is continuous. But it is continuous variable. Okay, so therefore, I can very well calculate mean, nothing to worry about it. And if this is my objective, then hypothesis which I will write will be like this. I will just copy and paste and just write. There is no significant difference in mean scores of English reading comprehension of students studying in government, aided and private colleges. So please understand, in this particular one, I have the types of colleges, and I have the 3: government, aided, and then I have the private. And here my variable is that English reading comprehension. And I can develop a test for assessing the English reading comprehension. So you will have a score, and therefore we can analyze the data. There is absolutely no problem. So in this particular case, because we have the 3 groups, and we have one variable which has the 3 levels. So here you are using one way ANOVA. Okay. So let us now go to my SPSS. So I'm now going to my SPSS. Okay, this is my SPSS. Are you able to see this SPSS sheet? Hello, Chaudhary ji. Mr. Chaudhary, Dr. Chaudhary. Dr. Chaudhary. Any participant, please, are you able to see this? Any participant can unmute. Hello. Any participant can unmute. Hello. Chalo ji. If you are not, okay, fine, nice, no problem. Okay, so now I first go to the variable view. Suppose I have the gender here. And yesterday I told you that gender has got 2 levels. Now somebody was asking me the total width that you can have. So you can see here, it is 40. So your whole, the number, which is a whole number, it can be of 40 digits. Okay. And decimal, I will tell you just now. In the decimal, it is 60 up to 16 decimals. You can have the data. There was one question asked by a participant. भाई आप चौधरी को कौन हो? हाँ तो यार कोई तो जवाब देना मेरे को. चौधरी को वो कर क्या रहा है यार? उसको कह दो कि यार तुम एंकर हो तो भैया रहो ना.
Yes, sir, I'm there. Hello.
हेलो.
Yes, sir, I'm there.
अरे भैया तो पहले बताओ ना, मैं कितनी देर से तो पूछ रहा हूँ.
Okay, sir.
एंड और जब आपको अगर नहीं दिखेगा तो और मैं चलता जाऊंगा तो ऐसे कोई थोड़ी बात.
नहीं सर, it is visible. वो तो शुरू से दिख रहा है सर.
तो बेटा फिर भी आप मेरे को बताओ ना.
Sure, sir. Sure, sir.
Okay. All right. Suppose I have gender, and let us say I have the English reading, English reading comprehension. English reading comprehension, it is a continuous variable. Now we go to the data view. And the data view, so you have the gender. Suppose I am just entering the information of the gender. Okay. And now I am entering the data of the reading comprehension. Suppose I have like this. Okay. Now, why have I taken this particular example? Because I wanted to answer the question which I have given. Say, if I go to analyze and go to compare and then go to independent samples t-test, because there are two levels of gender. So I'll go here and English reading comprehension, I shift to the test variable, because English reading comprehension is a continuous variable and gender is a discontinuous variable, so it is grouping variable. And you know, the moment you say group, then it is not continuous, it is discontinuous or discrete. So you click it here and you say 1 and you say 2. Okay, and let us say this is the value. Now the t value that you get here is 0.33. Say it is 0.33. Nothing to worry. You need not to take the another one. It is 0.33. Okay. Let me analyze the same with the help of one-way ANOVA. It is, you go to compare means, and in compare means, the last one is one-way ANOVA. So you click it here, you get this dialog box. So your dependent list will be English reading comprehension and your factors will be gender. So you can shift it here. Okay. And let us say, okay, you want mean, fine, no problem. And let us say we go ahead. Now, this is my F value. My F value is 0.109. This is my F value. Okay. And my T value is 0.33. Now, if you square T square, that means 0.33 multiplied by 0.33. How much you have? Let me just calculate. So here I am going to calculate. So it is Please, can any one of you calculate? Can any one of you calculate?
Point, just a minute. 0.1089.
Okay, so therefore 0.1089. The meaning is that t square is equal to f. So that means when you have one variable having two levels, whether you analyze your data with the help of t-test or you analyze with the help of one-way ANOVA, both results will be the same. Okay, so therefore the relationship between t and f is t is equal to square root of f. I repeat, the relationship between the t value and f value when you have one variable having two levels, then the relationship is t is equal to square root of f or t square is equal to f. So it is because of this people do not use one-way ANOVA when they have the one variable having two levels, because the same answer you will get when you analyze it with the help of the t-test. So the t-test and this, both results will be the same. So therefore people do not use that. Now I go to the one, and now I will say take another variable, as I have taken in this case here. The variable was the types of colleges. So now I have another one, the types of colleges. Types dot of dot colleges. And you know there are three types of colleges I have. Now one will represent the government college. Colleges, and two will represent the aided colleges. And the three will represent my private colleges. Okay, so therefore this is what I have written. And you know that English reading comprehension, I have already entered the data. So let me enter the data of the types of colleges. So I'm just entering the data. I will enter the data of reading comprehension more. Do not worry about it. So let me enter the data of the reading comprehension. Okay, so I have entered the data. Okay, now we go to analyze, and my objective was to compare mean, scores of reading comprehension. So I am comparing the means. So I go to compare means. And because here I have the 3 types of colleges, and these are government colleges, aided colleges, and private colleges. So I have the 3 levels. So I have to use one way ANOVA. I cannot use t-test, because t-test can be used only and only if you have one variable which has got the 2 levels. If you want, still you can use one way ANOVA, no problem. But one way ANOVA is more beneficial when you have one variable having 3 levels. Because when you have one variable having 3 levels or more than 3 levels, the t-test can never be used. I repeat, whenever you have one variable which is a discontinuous variable and having 3 or more than 3 levels, you should never use the t-test. You have to use the one way ANOVA. Okay, so I go to one way ANOVA. Now reading comprehension I have already done. So I should take out my this gender. So types of colleges now I am entering. Now let us see the options. Do you want descriptives? Yes. Do you want homogeneity or variance? Yes. So you can take these 2 things, no problem at all. So now go ahead. Now, in this case, there are 3 groups. And if there are 3 groups, and if your F value may be significant, and if your F value is significant, it will indicate that the mean scores of reading comprehension of students studying in government colleges, aided colleges, and private colleges differ significantly. I repeat, if your F value comes out to be significant, then the meaning is that the mean scores of English reading comprehension of students studying in government colleges, aided colleges, and private colleges differ significantly. But if your F value is not significant, then the meaning is that the mean scores of English reading comprehension of students studying in government colleges, aided colleges, and private colleges do not differ significantly. Now, when they do not differ significantly, then we should not analyze the data further. But if your F value is significant, then it will reflect that these 3 means they differ significantly. And if they differ significantly, then you should know that which the students belonging to which college have the significantly higher English reading comprehension. And for that, you have to further analyze your data with the help of post hoc test. So let us analyze it right at present, and later on we will see whether we should use this or we should not use this data analysis. So we can have LSD or we can have Duncan's, no problem at all. There are 12, 6 on this side and 6 on this side, and different tests are to be used at different situations that we will see. Now here level of significance is 0.05. You can see if I continue here. Contrast, there is no need. We go ahead. Now this is my F value which you have got. So now you can see here that you have the descriptive. Your government colleges, there were 14 students, aided colleges, 18 students, and private colleges, only 12 students. And these are the mean scores of English reading comprehension. And these are the standard deviation, these are the standard error, and this is your limit. You know, the lowest and the highest, so you can find out that. Fine. These are the minimum scores and maximum scores you have entered. Now, this is test of homogeneity of variances. Now, here, the error is 10.6%. This is 0.106, and if you multiply it by 100, it will be 10.6. And when it is 10.6, then the error is more than 5%. And since error is more than 5%, that means this value is not significant. And if it is not significant, that means whatever are the differences in respect of reading comprehension of government colleges, of aided colleges, and private colleges do not differ significantly. So homogeneity of variance condition is satisfied. Okay. Now this is your one-way ANOVA. And in this one-way ANOVA, your F value is 0.096. And the significance given here is 0.908. And if you multiply it by 100, then it is 90.8% error. I repeat, your significance, which is given here, is 0.908. And if you multiply this by 100, then it will be 90.8%. So 90.8% error. And your error can be maximum 5%. So it is more than 5%. That means this value, this F value is not significant. I hope you have understood it. Okay. So therefore, now let us note down these values, and then let's say, how do I test my hypothesis? Okay. So you can note down these values. My DF is 241 and 43, and my SS value is 4.42, and then NRG is 9.49, and my MSS value is 2.21, and 22.91, and my F value is 0.10, because this value is 0.096, so I can say 0.10, no problem at all. Okay, so this is what the important is. Now, since this value, F value, is not significant, the meaning is that the mean scores of English reading comprehension of students belonging to government colleges, aided colleges, and private colleges do not differ significantly. And now, if I show you further, you see you are this Duncan's multiple range test. This is Duncan. It is written, see my cursor. So this is Duncan's, and all these are in one particular column, and the error is 69.9%. And since all mean are in one particular column, that means they do not differ significantly. Okay, now let us proceed further and see how do I test my hypothesis and do the interpretation. Okay, now I am sharing I'm sharing my Word document. So I share the Word document. Okay. Are you able to see this Word document? Chaudhary. Chaudhary. Okay, don't worry. All right.
जी सर, we are looking.
हाँ तो यार immediately reply करो ना. सो रहे हो क्या?
Sir, there is some sound issue, sir. Your voice is fluctuating.
My voice is not fluctuating. There is a problem in your system, not my system.
Okay, sir.
Because
Ji,
you are listening from your system, not to my system. So take care of your system.
Gupta, sir, please ensure that the sound should be proper. Candidates are saying.
So everybody should check their own computers, whatever the system you are using. Okay. So now, from the objective was to compare mean scores of English reading comprehension of students studying in government, aided, and private colleges. So from this, let me make a caption heading. So caption heading is types of college-wise comparison of mean scores of English reading comprehension of students. Now this caption heading has been taken directly from the objective. So every time, the moment you change your objectives, the caption heading will change, because your variables will change and other things will change. So let me now write. I am copying this because I need not to. So the objective was to compare mean scores of English reading comprehension of students studying in government, aided, and private colleges. There was 3 levels of colleges, namely government colleges, aided colleges, and private colleges. Okay, thus the data were analyzed with the help of one way ANOVA, and the results are given in table 1. But you should have a continuous table, because in the same chapter there might be 10 tables. So you have number continuously, but here it doesn't matter. Okay, so now I have table 1. So I will see what is the caption heading of the table I will write. Now I am inserting the table. So this is insert the table. I want auto fixed. So therefore you will have auto fix. Now the first will be the source of variance. What are the sources which will be responsible for bringing some differences? That is the meaning of sources of variances. Another is a DF, the degree of freedom. Another is SS. SS means sum of square. And another is MSS, mean sum of square. And another is F value. Okay, now in this particular case, my one source of variance is types of colleges, and another is error, and another is total. Now my degree of freedom for types of college is 2, as you must have noted down, and my error is 41, and the total is 43. The sum of square value is 4.42. Then next is 939.49. And then mean sum of square is 2.21 for the types of colleges, and mean sum of square for error is 22.91. And my F value is 0.10. Now I will tell you how we get these SS value and MSS value, nothing to worry about it. So here, this will be summary of one way ANOVA of English reading comprehension of students. Okay. Now, before giving the interpretation, let me see how we calculated sum of squares for types of college and sum of squares for error. See, sum of squares for types of colleges equals to the No, this I should tell you mean sum of squares. Because these sum of squares we have got from the title, I can tell you that later on. So mean sum of squares for type of colleges is sum of squares for types of colleges divided by the degree of freedom for types of colleges. And that makes your sum of square for types of colleges 4.42, and this has to be divided by 2, and if you divide it by 2 it will be 2.21. So this is how we calculated the mean sum of squares for types of colleges. Now let us say, how do we calculate mean sum of squares for error? So it is sum of squares for error divided by df for error. And you know, error sum of square is in 939. So 939.49, and this has to be divided by the degree of freedom, that is 41. And if you divide this by 41, so answer you will get 22.91. So this is how we calculated the mean sum of squares for the types of colleges and mean sum of squares for error. So whatever is your sum of squares, you divide this by the corresponding degree of freedom, and then you will get the mean sum of squares. Now, how do I get my F value? So F value you get is equal to the mean sum of squares for types of colleges divided by mean sum of squares for error. Okay, and therefore if this is so, then what I do is that 2.21, this has to be divided by 22.91. When 2.21 is divided by 22.91, your answer comes out to be 0.10. And this is how we have got MSS and F value. Now this F value is not significant, so you need not to write anything. So let us now see, how do I test my hypothesis? So I start testing the hypothesis from table 1. It can be seen that the F value, please, F is capital, it is not small. D is small, F is small. Sum of square SS, both are capital. Mean sum of square, M is capital, S is capital, and again S is capital. So you must understand all these things. So from table 1, it can be seen that the T value is 0.10, which is not significant. See, whenever the value is not significant, you should not write the level of significance. Why? because whenever it is not significant, that means it is not significant at 0.05 level, because maximum allowed error is 5%. So if you say it is not significant, so automatically it is understood that it is not significant at 0.05 level. So nothing to worry about it. And when you are not writing the level of significance, you need not to write the degree of freedom. The degree of freedom is to be written only and only when your F value is significant. Otherwise, you need not to write. Okay, all right. So now it indicates that the mean scores of English reading comprehension. So I'm just copying paste. Mean scores of English reading comprehension of students belonging to government colleges, aided colleges, and private colleges. Okay, do not differ significantly. And when they do not differ significantly, then my null hypothesis is not rejected. Thus, the null hypothesis that there is no significant difference in mean scores of English reading comprehension of students belonging to government colleges, aided colleges, and private colleges. Is not rejected. See, the moment I write is not rejected, that means my hypothesis has been tested. Now, it is the third sentence which I have written, and that indicates the hypothesis. And the hypothesis has been tested. So this is how the analysis has to be done for testing the hypothesis. And I proceed further. Now it may therefore be said that students studying or students belonging to students studying in government colleges, aided colleges, and private colleges were found to have the reading comprehension to the same extent. were found to have English reading comprehension to the same extent or same degree. Now, once I take this, it becomes my finding that students studying in government colleges, aided colleges, and private colleges, okay, I can write colleges, were found to have the reading comprehension to the same degree or to the same extent. Now this becomes my finding. So from here to here becomes my finding. So if you move systematically, then writing finding is not a problem. Now let me take another example. And now I am taking example of one experimental study. And let me write the objective. And the objective is, okay, let me tell you the situation. The situation is, I have methods of teaching. All of you know the methods of teaching. There is absolutely no problem in that. And suppose we have the 3 methods of teaching. One method of teaching is say discussion method. Okay. Another method of teaching is say a demonstration method. Another method, let's say lecture method. Suppose these are the 3 methods of teaching. Okay, so therefore your methods of teaching is a discontinuous variable. Okay, and since you will be teaching, so this will be methods of teaching is independent variable. Independent variable. Why independent variable? Because it is the treatment. So you have to teach a group. Let us say you are teaching, suppose for example, say you are teaching, let's say mathematics to class 12 students. So one group you will be teaching with the help of discussion method, another with the, okay, it is demonstration, so I can't take mathematics, so I have to take physics, let's say. So one you teach with the help of discussion, another you teach with the help of demonstration, another you teach with the help of lecture method. We have to teach the same content for the same duration. So physics is all right to the students of, let's say, government schools, government, say, senior higher secondary school, senior higher secondary schools. Please mute yourself. Hello.
Ji sir.
Organizers,
Ji sir.
please
We
mute.
are looking.
Mute. This person.
Yes, we are looking your PPT.
I am not saying PPT. There is a external noise coming. Somebody has unmuted, so he should mute. You should unmute her. All participants should mute. Okay. So therefore, you will be having, because I'm teaching physics, so you will be having achievement in physics. So this will be your dependent variable, the achievement in physics. Okay. And now you know, let me now write the objective. Keeping these values, this information in the mind, I am writing the objective to compare mean scores of achievement in physics. Achievement in physics of students taught through discussion method, demonstration method, and lecture method. And if this is my objective, then let us say what is my hypothesis. Then my hypothesis is there is no significant difference in mean scores of achievement in physics of students taught through discussion method, demonstration method, and lecture method. So now you know, here I have one continuous variable, that is achievement in physics, and my treatment, you can say independent variable, or you can say treatment also. So you can say the treatment. So method of teaching is a treatment, or methods of teaching can be an independent variable. You can use these words interchangeably, no problem at all. So now I go to my SPSS, and then let us take some data and then go ahead and how I will analyze and write the interpretation. Okay. So therefore now I'm again going to share my, this is my one. So I'm sharing it. Okay. So now let me go to my variable. So my variables now are changed. One is methods dot of dot teaching, and there are three methods of teaching, and these three methods of teaching, number one is my discussion method. Let me see, I think it is a discussion method I wrote. Yes, it is discussion method. Okay. The second method was demonstration method. And the third was my lecture method. And then here I have achievement in achievement dot physics. And it is a continuous variable, so perfectly correct. Let's go to the data. So now I have to have methods of teaching. So suppose I'm first entering the data of those people who were taught with the help of a discussion method. Your number of the subjects in each group may not be the same. You need not to bother about it. That means the students who will be taught physics with the help of a discussion method, the number may differ than the students who will be taught physics with the help of demonstration method and lecture method. That may be different, nothing to worry about it. Or what I can do is I can just copy and paste. So if you have many, then you can copy and paste also, nothing to worry about it. Okay. Now, if I want 3, so I can write 3 and I can again copy and paste because it is 3, 3, so nothing to worry about it. So I have done this. I proceed further. I have done this. I proceed further. So suppose I have so many people. All right. Let me now go to my, now I have to put the achievement in physics. Okay. So let me take the maximum marks is 50. So let us take the scores. Oh, sorry. Okay. So just if you have the Spss, so you can also enter your score simultaneously. So I am entering the data for the lecture method group. Okay, I have entered the data. Now let me go to my analyze. I go to my compare means, and then I go to my one-way ANOVA because I have the 3 groups. And if I want to compare the mean scores of achievement in physics, then I have to use one-way ANOVA, and this I reset. So my achievement in physics is the dependent list, it should go. Then methods of teaching will be the factors. In the option, I want mean, standard deviation, so descriptives I want. Let's say homogeneity of variance test you want, go ahead. Then post test. post hoc test. If your F value is significant, then you will definitely like that which group mean scores of achievement in physics is significantly higher. Let me see, I'm just saying one, Duncan's, the complete name is Duncan's multiple range test. I repeat, Duncan's multiple range test. And if you have to read more about it, you can note down the name of the book, Experimental Design. I repeat, Experimental Design by Alan, A-L-L-E-N, Alan Edward, E-D-W-A-R-D. So this book gives you the Duncan's multiple range test. All books do not give, so you can use it. So I continue, and let's say I continue. Okay, now this is my F value. Now this is my N. These are means, these are standard deviation, this is standard error and all that. Okay. And now here your 11th test of equality of variances, it says it is significant. Yes, it has to be significant because these are the scores you are taking after giving the treatment. I repeat, these are the scores you have taken after giving the treatment, and because the treatment had their effect, therefore there will be differences in the achievement in physics of the student. So do not worry about it now. Now this is your F value. So let us see how do I take these F values. Now here one is my methods of teaching. Another is my error. See here it will always be between groups. But between word is used only when you have two groups. But if you have more than two groups, then you cannot use the word between. Then you have to use the word among. A-M-O-N-G, among. So therefore, don't worry about it. Below this is written within group. So within group is error. And then the total. And that the degree of freedom here is given. Methods of teaching 2, error is 90 and total is 92. The sum of squares for your methods of teaching is 3079.74 and for error is 1088.99. And then my MSS is for methods of teaching is 1539.87 and for error is 12.10 and my F value is 127.26 and this value is significant at 0.01 level. This is 0.00. That means the value is significant at 0.01 level. Okay, so let us see from here how do I interpret my data and how do I write my other things. So I now go to my, say I again share, and now I am sharing my the document file. This is my document file. So therefore, now. So therefore here, let us first write the caption heading. And caption heading is methods of teaching wise, mean methods of teaching wise, comparison, let me shift on one page, teaching wise, comparison of mean scores of achievement in physics, of students. Methods of teaching wise, comparison of mean scores of achievement in physics of students. Okay. Now here I say the objective was, let me copy the objective so that I save my time. This is my second objective today. If you like, I can write the second objective was to compare mean scores of achievement in physics of students taught through discussion method, demonstration method, and lecture method. Okay, so I can copy this and I say there were. It has to be written in the past tense because you have already collected the data and now you are analyzing the data. Okay, so the data, there were 3 types of methods of teaching. Namely, lecture method, okay, discussion method, and this. Thus, the data were analyzed with the help of one-way ANOVA and results are given in table 2. So I'm saying table 2 and I'm just entering one table here, insert a table. And you know, I always insert auto fit because all my columns may be of different size. So it is source of variance. Next is degree of freedom. Next is sum of squares. Next is mean sum of squares. And next is F value. So now here, number 1 is methods of teaching. Please never copy the SPSS output and write and use for interpretation. No, because in the table which you have in the output, SPSS output, lot of informations are given and you may not use all. So just note down the information which you require. Rest you leave it. Error, then total. Your DF here is 2, then this is 90, and then this is 92. 90 plus 2 is 92. Your sum of squares is 3079.74 and 1088.99. Then mean sum of squares is 1539.87. Okay, so it is 0.87. And then this is 12.10 and your F value is 127.26. And this value is significant. So there are two ways to represent the significance. If it is significant at 0.01 level, so I can put a double star here, and below this I can put double star and I say significant at 0.01 level. This is the one way which some of the researchers, they used to indicate the value whenever it is a significant value. If it is not significant, you need not to bother about it, because then you have not to write anything. But if you do not want to use the double star, then you have to write like this. Now I add one more column here. I'm inserting the column, and here I'll say remark. Okay. And when I'm saying, you see everything has changed. So therefore I have to now reduce my font size. So I'm reducing the font size. I'm sure all of you can see it. Okay. Now remark is P is less than 0.01. So P should be now small. So if you do not want to write the double star, then you can write like this. The choice is yours. If it is significant at 0.05 level, and if you have to represent it by the star, then single star is to be used for indicating that the value is significant at 0.05 level. But if it is significant at 0.01 level, then you should use double star. Okay. So therefore, this is, let us say, what is this? This will be summary of one way ANOVA of achievement in physics of students. Now let us see how do we write now. From table from table 2, it can be seen that the F value is 127.26, which is significant. And when it is significant, then it is important you should write the level of significance, which is significant at 0.01 level. And whenever we write the level of significance, then we must write the degree of freedom is significant at this with degree of freedom equal to. Now see, there is 1 degree of freedom for methods of teaching, that is 2, and another degree of freedom is error. So I have to indicate both. So either I can write, put a bracket and say 2, 90. So the first degree of freedom is for methods of teaching, and the second degree of freedom is for error. If you do not want to write like this, then you can write like this, 2/90. So the choice is yours, how you want to indicate your degree of freedom. Okay. Now F value is significant. F does what? It helps in comparing the mean scores of the 3 groups. And F is significant, that means it shows that there is significant difference in mean scores of achievement in physics of students taught through those 3 methods of teaching. You know, taught through discussion method, comma, demonstration method, and lecture method. And you see, F value is significant, that it shows that there is a significant difference in mean scores of achievement in physics of students taught through discussion method, demonstration method, and lecture method. Thus, the null hypothesis that there is no significant difference, I'm copying and paste so that I save time. So there is no significant difference in mean scores of achievement in physics of students taught through discussion method, demonstration method, and lecture method, okay, is rejected. Please see, the moment I write this, that means it is now hypothesis has been tested. Thus, the null hypothesis that there is no significant difference in mean scores of achievement in physics of students taught through discussion method, demonstration method, and lecture method is rejected. Because there is a significant difference, and null hypothesis says there is no significant difference. Now, in order to know which group which group's achievement in physics is significantly higher than others. The data were further analyzed with the help of, now just see, I had used Duncan's multiple range test, so I can write that, were analyzed with the help of Duncan's multiple range test, and the results are given in table 3. So I have to go back the output. So because there is no time, it's already 4:47. So next lecture will be there on this webinar. So therefore I stop it here, and tomorrow I will use the same output and I will be using the same sheet for interpretation. So need not to worry about it. And the questions which you want to ask, you can note it down and you can ask tomorrow. So anchor, please, Chaudhary, announce this. Thank you very much.
Thank you, sir. It's a request to all the participants to please note down the questions and send it in the question answer box so that we can jot out the questions, and we'll have the discussion about the questions before we start tomorrow's session.
So we can close now.
Yes, sir. Thank you. Thank you. Thanks a lot, sir, for your precious time. Thank you, sir.
Thank you very much, Chaudhary. Nice. Thank you.
Thank you, sir. Good day, sir.
All right. Same to you.